Hi there, welcome to LLM App Simulation tutorial. My name is Emily Jal. I'm a CTO at Evidently AI. Recently we had a release where we open sourced two nice components. It's datasets and tracing. Today in this tutorial I will be showing you how we can use both to evaluate your LLM-based applications. I will be solving content generation task, and with help of Evidently and Tracely, I will be comparing different instructions to make sure I generated the best engaging tweets. Before we proceed, a few words about installation. I already installed Evidently and Tracely to my virtual environment, and my Jupyter notebook is running locally. Let us quickly go to the terminal. So my Jupyter notebook is running, and now let me run Evidently UI service. Now we are talking about the open source version, so I run it locally, but we also do have a hosted version of Evidently Cloud. To run the local one, I go for Evidently UI command. We have help, we have a lot of parameters, but I'm going for default ones. So it's running the service locally. I'm copying the address. Let's go to the browser, and here we go. So far it's empty, there are no projects, but we can create one. We can do it either with help of UI by hitting the plus button, or with help of the code, and I obviously prefer the second version. So yeah, finally back to the task. I would need to write a code that generates for me tweets on some topics. For doing that I will be using OpenAI. Let me import it quickly. I would need to create a client, and all my API keys, secrets are already created as environment variables, right? So you can see it here. And I need to create some topics to generate tweets about, right? And here are my topics. I already created a list. It's all about testing in AI engineering, CI/CD, some LLM apps evaluations, all very nice and interesting. It's here, and now let me just create a function which will be writing the tweets about my topics. As promised, it's OpenAI library, so I use responders create API. It generates for me a text. And I also might need to have an access to some information about tokens, because I do believe that it's important not only evaluate the quality of the text generated, but also trace how much tokens did you spend for generation of this or that piece of information. Might be quite insightful. Nice. So now let me cover it by a simple function. I will call it basic tweet generation. And well, as the parameters, I have topic, model, instructions, and now I can play around with different instructions and different models and see what works best for my task. Just a quick check if it works. It works. Nice. Let's proceed. As promised, I will be using Evidently and Tracely, and for doing that it needs to be installed locally. And let me import a couple of things from Evidently. It's datasets, reports, data definition, bunch of different descriptors, but what is important here is the workspace. You have different options. The workspace, which operates on top of the file folder, the less production and very simple version. Also, we do have a remote workspace and the cloud workspace. For now, just the local one. So all the data, all reports or traces will be stored locally on my folder. Also Tracely. So I need to organize a tracing, right? And that's how I create my Evidently client. I use the workspace, this one, right? And here is the path to my local folder, which is just the workspace. Also, now I can create a project. Let me do it with help of client create project command. And here is the name. So what has happened? So let's actually create the client. And now I can have my project. So if I go here, I will be able to see that this project is already created, but so far it's empty. Let us fix that. Going back to code, and let us initialize the tracing. So the data will be sent to this address. Basically, it's right there, right? So that I can send all my traces to my project. Here is the project ID. I basically derive it from the project object, this one. The name of my traces, right? And as global equals to false, which means that I might have several traces inside of my environment right there in Jupyter notebook. Here we go. You can see it works on top of OpenTelemetry. And now let me update my tweet generation function a little bit so that I can track not only the output but also some tokens. How to do that? I'm just getting the access to the current span. Here I go, and let me update it with the usage. So I add the dictionary with input and output token here, and it all will be tracked down by Tracely. Cool, so now let me actually generate some tweets. I do it right there, so I just call my function in a cycle for all my topics. And while it's generating, let us go back to the service and see what we have now. I'm navigating to traces, and I can see that my trace basic content generation is already there. Let me view it. Oh, it's already done, right? So it was real quick. And I can just browse it one by one, like here. The structure of my function is very straightforward. It's just a single function, right? Less than 3 seconds to generate a tweet. And all parameters are here. Topic, model, tokens, result. Lovely. I need to say that you have different view options for your traces. For instance, the dialog is very nice. In case you're interested in reading the data like in a raw format, you can go for it. And for instance, I can check all the topics and final results, which is very nice for ad hoc analysis and just understanding on how does the app operate. Lovely. So going back to the code. Of course, it's nice to just read through the data and understand what it is, but for the proper experiment management, we need numbers, we need metrics. So let us basically get the information about our traces. I needed this ID. You can also copy it directly from the service, but I prefer to get everything in code, right? And now with help of Workspace client, let's just load the dataset back from the service to Jupyter. Here we go. We do have dataset data definition, so evidently understands how to parse data correctly, right? And here is the dataset in the data frame mode. We do have ID, timestamp, link to the trace, and of course all the valuable information like the result, inputs, model, topics, everything we need to run a proper evaluation. Now let's move on to our criteria, and as I promised, I want to generate engaging tweets. So to see whether my tweets are engaging or not, I will be using evidently LLM as a judge approach. To do that, I use binary classification prompt template, which basically will determine whether my tweets are engaging or not, and here's my criteria. It is very customizable. I'm sure you guys can come up with better criteria, but mine is pretty straightforward. So it's engaging whether it contains some strong hook, uses emotions, humor, maybe encourage some interactions, and it's neutral if it just states fact or observation or lack like clear personality, tone, or call to action. So that's, I think, very straightforward. So that's my binary classification prompt template. This is the basis of my LLM judge. And also I will add more descriptors like text length and sentiment. So we need to have not very long text and preferably not negative. Here we go. Let's now calculate it and add to the initial dataset. And let's check if it's here. So I scroll to the last columns. Cool. I have my length, sentiment, tweet quality, together with the reasoning. Nice. We have very small data set, but realistically, if you do have like thousands of rows, you won't like analyze it one by one, right? And now we can have our report, which basically summarizes all the statistics. As metrics, I choose text evals. That's a preset of metrics specifically designed for text evaluation. Here we go. The report object is configured, and now I can run report evaluation on top of my dataset, and I will add some text like the model version, the information like basic generation, so that I can later add it to my UI service with all those texts. Quick preview. Here it is. And let us just add it to the client. Yep, it's here. So now if I go to the project, let me open up reports. Here is our report. So if I hit view button, I will see the length distribution, well, okay, quite long tweets. Also the sentiment, well, very positive, nice. But unfortunately, no engaging tweets, not a single one. Okay, now let's optimize our instructions because obviously I need some help. For doing that, I will be using prompt optimization from Evidently. Let me quickly import it. I will be using prompt optimizer, prompt execution log just to show you, and some parameters. To run it, I need to implement a function which creates the prompts, so it will be a function which outputs pandas data series with some actual tweets, right? And I would need to create LLM judge. It's an object which will be reading all those tweets and checking whether they are engaging or not. So the function to generate tweets is super straightforward. I just copied my topics and said, well, here is the generation. So basically I run my tweet generation function for all the topics and return the result as the pandas series. That's it. And to create my LLM as a judge, I will be basically reusing the template we generated to check whether tweets are engaging or neutral. Very handy. So here is the column to use. It's tweet generation result, template, provider, model, and just an alias. That's it. It's done, and now we can actually run our optimization. So as optimizer, we use prompt optimizer object from Evidently. The strategy is feedback based, so we ask our judge to actually score all the tweets, give some feedback, and based on this, we will be improving the initial instructions. And we said that we're doing it in async mode. We are going to start from the prompt tweet generator. That's it. And to speed things up a little bit, I will have only 2 repetitions, so that quite often when we do solve optimization tasks, if we started from the unlucky place, we might never converge. So we just will be having like 2 tries in this case. It does take some time because it's quite a lot of evaluations to be performed, but it's actually very, very handy because you do not need to write your prompt yourself, so you just wait until Evidently does it for you. As I can see, it's already the final run. Lovely. And it's done. Let us see how our best prompt looks like. We do it with help of optimizer best prompt method. Here we go. You're a tweet generator that creates engaging and compelling content tailored for social media. Wow! I wouldn't be able to do something like that myself. And you can see that it does not include any actual examples or nothing like this, so it's pretty generic instructions. You will be able to generate quite a lot of content having these instructions as the base prompt. Perfect. Also, if you're interested, you can print out some optimization statistics. And I will be moving to the second experiment, so I will be creating new tracing dataset. I call it optimized content generation, same project, same address, and again, not global. Cool. Now I have a place to store my new traces, so now let me generate it with help of the new instructions. You can see that as an instruction, I use here our optimizer.bestPrompt, and I decided to update the model as well, so that we cannot directly address the effects to either prompt or the model, but I do believe that the prompt is really nice. So let's see how it looks like inside of the project. I'm going back to traces, and now you can see that we have both basic content generation and optimized content generation. Nice. I hit a view button, and lovely, all my 5 traces are there. Okay, so let me quickly load it back to the Jupyter notebook. I'm loading the dataset, adding the same descriptors, sentiment, text length, and engagingness, like LLM as a judge. Here is the data frame. Everything is right there, so let me quickly run the report with the same structure. Here it is, all our statistics. Oh, it became less positive, but very engaging, very interesting. So let me load it back to the service and let me see it. Now I can see both old and new report right there. Let me see that. Oh, lovely. So actually I never showed to you the actual tweets. So we can see it either from tracing or from right there. So if you go for the column tweet generation result, you can see that now it's very nice actually. It includes quite a lot of different emojis. So yeah, I do believe it's more positive now. Yeah, it has some hashtags. Yeah, I believe we did a great job with help of evidently optimization. I think that's all I wanted to share with you guys. Now you know how you can use datasets and tracing to evaluate your experiments and get the best possible solution. And I do hope you like this video. Please let us know what you think in the comments. Bye bye.